Hello everybody, welcome to this podcast. This podcast is delivered from Michael Silber, who is the event director for Power and Utilities Australia, an event being held here in Melbourne this August 14th-15th. Michael is interviewing one of our keynote speakers, Mr. Patrick Lee, who is the CEO of PXiSE. Patrick will be speaking at the event about the company's activities in Australia, as well as his vision for the future of the electricity industry in this region.
Hi everybody, this is Michael and Patrick. Very pleased to meet you. How are you today?
Hi, nice to meet you, Joe.
In Australia, I know you've worked with Horizon. Can you tell us a little bit about the Horizon project and what that's brought to the end-use consumer in Western Australia?
Yes, so the Horizon Power project centers around, I would say, community in remote area where they have built a utility network system powering, I would say, a few hundred homes or maybe 1,000 homes, where you also have businesses surrounding it. And as the area grows, so does the complexity of the system grow. And so utility have some asset that they control at a substation. It could be a battery or a generator. And because of old technology, most of these remote community grids are still running largely on fossil-based generation. Mm-hmm. Even though they have some solar rooftop and some battery adoption, they are, I would say, operating within maybe 20%, 20+% of renewable. They couldn't really go beyond that because they're relying on the fossil generation to anchor the operation. And so the opportunity of adopting PXiSE is to be able to allow them to transition to higher percentage renewable and slowly phase out the fossil fuel generation. And because the solution that we provide based on the specification also provide interaction with customer-owned DERs. And so it can tightly integrate customer-owned DER, utility-owned DER into a large network so that we can unify the control of all of the DERs. As the system grows, you may have community now that are start connecting to each other. So when you have one area able to connect to another area with a distribution line, the ability to reshape your power supply and demand at one community allow you to reshape, when you have energy available to share with another community. So that provides the basis of transactive energy using a microgrid concept. And in Horizon Power, you build a microgrid first, and then they try to network the microgrid with other areas. Yeah. So we will eventually end up in the same place, right, whether you're starting from a large network or starting from a microgrid. But I think what we solve is the common architecture. To get there, you have to have a truly functional microgrid that has good visibility and control in order to provide the reshaping of the energy profile so that you can control when you actually consume from the grid and when you can contribute to the grid.
So it really is a great example of the sharing economy, almost transactive peer-to-peer over a network of microgrids, correct?
Yeah, I think you put it correctly. I think in terms of the sharing economy of a power system is exactly the way it's designed in Horizon Power, where customer have many ways, even though they are structured one way to share within Horizon Power, but it opens up the door for other opportunity to have more free form of sharing. As long as the control system support the transaction structure, whether the customer will share the energy with the utility, controlled by the utility, or the customer can peer-to-peer trade down the road, this platform will support that.
That's good. Give us kind of a brief preview of what our audience can expect to hear from you during the conference.
So I think at the conference, I want to talk more about how renewables progression is occurring rapidly. And as the grid transitions from a one-directional centralized power plant to a bi-directional, highly distributed, highly integrated renewable grid, it really takes a more advanced control technology to enable that. However, I think oftentimes people think that maybe there's only one way to implement a large integrated network of a two-way flow, highly distributed asset in the utility. where I think a lot of the big vendors are pushing for a large integration of IT and OT system first. For example, many people talk about advanced distribution management system where you have to have your geographical information system integrated with the customer information system, with the outage management system, with the distributor management system, basically tying everything into a model that you can kind of work on. And it takes multi-years and a lot of money to invest into a process like that for the outcome of able to manage distributed resources. I think we start from an operations side to look at, well, what does it take to enable DERs to be able to transact in a shared economy? How does it work with utility? I think the messaging to the audience is that there are alternatives other than large IT/OT system integration to build out your information structure first before you can tackle problems that you have. I think that's a more pragmatic approach that we can offer people.
I think that'll be widely anticipated and appreciated by our audience. That's, I think, a really good theme. I think this is for the pre-show interview. I think we've covered it all here, Patrick. Listen, Patrick, I appreciate your time. This is fantastic. We look forward to seeing you in August.
Yeah, we're looking forward to that.
We're all very excited to welcome Patrick Lee, who will be delivering a presentation to the audience at Power and Utilities Australia. As you just heard, Patrick's presentation will address the collaboration with Horizon Power and how that project achieved greater renewable integration into a microgrid. Please come and join us on August 14th, 15th at the Melbourne Exhibition and Convention Centre to hear Patrick and the rest of our speakers discuss strategies and solutions for the energy transition. Head across to powerandutilisaustralia.com to register.